Hi, I'm Mrs McTaggart. In this video we're looking at the higher topic of vectors. This is the third lesson and we are looking at collinearity. Now you've met collinearity before if you've already done the straight line topic when you're asked to prove that points are collinear. This is pretty similar. So you might remember from straight line that collinear means parallel and all like running on the same line. So in terms of vectors, if you're told that a vector A to B is the same as vector C to D, that means that they are parallel and that AB is the exact same length or magnitude as CD. Now let's remind that A to B is the same as B minus E here using your position vectors. Now in a similar instance, if we tell you that AB equals 2C to D, it simply means AB is twice the length of magnitude CD. So we're starting to write it in a little bit of a ratio. And to prove, this is your method, to prove that 3 points are collinear, i.e. lie on the same line, we need to show that two of the vectors are parallel and that they have a common point. So A to B and C to D don't have a common point, they're just parallel. But if I was talking about a line ABC, we could treat B as a common point in the middle. And if we can find that A to B and B to C are the same or indeed like a multiple of the same vector, we can prove that they are collinear. So the best way to show this is get into examples. So here we're asked to prove that the points A, B and C are collinear. Now this works in 2D like you've seen before, or 3D, whereas before you found the gradient, now we're finding the vector from A to B. So let's have a wee look. So what I'll do is I always draw a straight line first. So we're given the points A, B, C. And I'm going to split it into the vectors A to B and then B to C with a common point B. That is not the only method. Some people might find A all the way to C. So sorry, what I'm going to say, I'll just repeat. I'm going to find vectors A to B and then I'm going to find the vector from B to C. But some people might find A all the way to C and then compare it with either this one or this one. It doesn't really matter. If there's letters involved, I sometimes, like unknown letters, I sometimes change my order. Either way, we're going to find A to B and then B to C. So A to B will be B take away A, which you met before. So that will be 5, 2, 5, take away 3, negative 1, 0. Okay, and if we work that out, we get, I'm going to work this way, 5 take away 3 is 2, 2 minus minus 1 is 3, and 5 take away 0 is 5. So we get that for vector A to B. That means nothing just now until we go to the same for B to C. So B to C will be C minus B. Notice how you're going backwards the way you always did with straight line as well. You always went y2 minus y1. So we're doing the second vector take away the first one. So we're doing 9, 8, 15. Take away 5, 2, 5. And this will give us 4. 8 take away 2 is 6, 15 take away 5 is 10, so it'll give you that. Now notice this one has a common factor of 2, so I'm going to remove a common factor of 2, which leaves me with 2, 3, 5. So notice that both of these vectors are 2, 3, 5, or a multiple of 2, 3, 5. This is what you're looking to get. So because they are both multiples of the vector 2, 3, 5, you can say that they are collinear. You can say that they are also parallel to each other. Now, in terms of what we write, this is one of these bits in maths where there is a sentence to write and I've already got it prepared. So what I've written is, since AB equals half BC, so if you look, AB was only one of the vectors and BC was a multiple of 2 of the vectors, so we say it's a half. So since AB is half of B to C, AB is parallel to BC. There's an H gone missing off my sentence, apologies there. With a common point B, therefore A, B, C are collinear. Now this is a heck of a sentence to remember, but it's one of those ones you have to write if you want to get full marks in your exam. Now, out of interest, this is a bit that sometimes people struggle with, is thinking about how do you know which way around to do that? So if I had a look, we obviously worked out that A to B was one of the 2, 3, 5 vector, and we worked out that B to C was 2 of it. So A is half, the AB part is half of BC. There is another way of writing it which I've got hidden underneath this rectangle. I've got it in that B is said to divide AC in the ratio 1 to 2, and you can see that from a picture up above. I've got one part for the A to B and then I've got 2 parts for the BC bit. Now that isn't really necessary today, but it will be important in the next lesson, okay? Let's do another example. Right, this time we're told that these ones are collinear and we've defined the value of k. These are quite common and they're a wee bit trickier. But I'm going to draw a little sketch first of all. So we've got D to E to F. So I'm going to work out D to E first of all, and I'll have numbers for that bit. So D to E will be E minus D, which is 3 to negative 3, take away 1, 3, negative 4. And that will give me 3 take away 1 is 2, 2 take away 3 is minus 1, minus 3, that will be a double negative, so it will be minus 3 plus 4, which is 1. Then I'm going to find an expression for E to F, because obviously there's going to be a letter in part of this. So E to F will be F minus E. So that will be k negative 1, 0, take away, and E will be 3 to negative 3. So this will give me k minus 3, minus 1 minus 2 will be negative 3, and 0 minus minus 3 will be positive 3. Okay, now here comes the tricky bit. So because we were told these were collinear, we know they're multiples of the same vector. Now disregard the top line for a second. Can you see that the one on the right hand side looks like it's going to be triple that one over there? Yeah. So what we can say is that the vector on the left is, the vector on the right is 3 times the vector on the left. So 3 of this vector would be equal to this vector. And then all we have to do is kind of focus on this top line. 3 times 2 is 6. So 6 equals k minus 3. Just like a normal equation, take the 3 over, 9 equals k. So the value that would work would be k equals 9. Because if k was 9, this top number here would make it 6, which is triple the 2. So final answer is k equals 9. So that's the wee tricky bit for that bit. But you just apply the collinear method as normal and then see how you go on from there. Okay, I have one more example. It's similar, but this time we've got 2 unknowns in our equation. So we're told that A, B and C are collinear and we have to find Y and Z. So again, as always, I draw a little straight line. So we're doing A to B to C. Now I'm looking where my unknowns are. My unknowns are in B and C. So for this one, I'm probably going to do A to B as my starting point. So that will be B take away A, which will give me 3 to Z, take away 1, 4, 2. And that will give me 2, negative 2. And we're going to leave this as Z negative 2. I don't like my Z's being with all these number 2's. Okay, and then I'm going to go find B to C. Now B to C is actually going to have a lot of unknowns, so I might go do A to C this time. So I'm going to do A to C, which is C minus A, so that I just don't have loads of unknown letters. So 7y negative 1, take away 1, 4, 2, which will give me 6, y take away 4, and negative 1 take away 2 is negative 3. Okay, so from there, let me just zoom up and create a wee bit more space for myself. Right, so A to B and A to C are both collinear. It's told us this in the question. Now, by focusing on the top numbers, I can see that the second one is triple the first one. So from that, I can say that 3 of my first vector will be the same as my second vector. And then I can form 2 little equations this time. So if I multiply the one on the left by 3, I can say that negative 6 is the same as y minus 4. So y equals, the negative 4 will go over, with minus 6 add 4, so y is negative 2. I can do the same with the bottom equation. I can say that 3z take away, if I multiply it with 3 first of all, 3z take away 6 equals negative 3. So 3z equals positive 3 and z equals 1. So in conclusion, y equals negative 2 and z equals 1 works in that one. So it's just playing around and remembering that you can actually do some very basic equations with vectors as well. I hope this has helped. Collinearity will come up again in the next video as well when we're talking about sharing on a ratio, and we'll talk a wee bit more of that. Thanks for watching. I hope it's helped.